Hello everyone, in this video I will be modeling this 2416 corner cap practice model and show you how my approach looks like. I haven't done this yet before, so let's begin. Let's reveal the drawing. Okay, so first thing I'm noticing is the units and the material. The units in mmgs and materials abs. Okay, let's set this one in SolidWorks. mmgs no material. I have a template set for mmgs no material, and I have 5 custom materials already set as favorites here: plain carbon steel, AISA 1020, 1060 alloy, ABS and cast alloy steel. So from here I will choose ABS. Okay, let's go to the drawing and let's check it out. First, there is no symmetry in this model, so there will be a lot of features. Okay, so we will start this in the front plane, and from this sketch we will sketch something like this and extrude it up to 60 millimeters. Okay, then that part will be formed. Then we can draw this part right here, selecting that face as a sketch plane, and draw this part and extrude it up to 7 millimeters. Then we can draw these 2 holes and we are done, and the fillet, and we are done. So this will take one feature for this part right here. Second feature will be this rib like structure right here. Third feature will be the fillet, and fourth and fifth features will be these 2 counter bore holes. Simple as that. So it will take 5 features for us. So let's start with this one first. Okay, for this we can take this one as the origin here and sketch something arbitrary like this and then assign dimensions to it. Let's choose the front plane, sketch, click on the line and draw that arbitrary sketch. Okay, nothing is crazy going on here, simple lines. Okay, something crazy just came up. There is an arc right here. Okay, let's draw the arc with a 3-point arc, just like that. Now we will assign dimensions to it. So let's assign the length dimension first, which is 155. Now we will assign this 55 dimension from here. Then we can assign this one as well. This one is 55 too. So from here to here, it's 55 as well. Oh, not a global variable. We want something like this. The radius is 560 for this arc. This one is 20 millimeters. This one is 9 millimeters. So let's zoom in and give it a dimension of 9 millimeters. There we go. We have a fully defined sketch. We are ready to extrude it up to 60 millimeters. Okay, let's go to extrude boss base and type in a value of 60 millimeters. Okay, we are done. Okay, let's change the color just for demonstration purposes. This is pink, something pinkish, as ABS often gives us a white kind of an appearance, which kinda is hard to look at. So let's give it something purplish. Now let's draw this rib as planned. We can draw this in the front plane or in this face. In this face it would be better to sketch it in this face, as whenever we are changing the model's plane or making it like move body or something, this rib will stick to this face, not the front plane. All right, let's I think we can start from this corner right here and go something like this, and there we go. And we don't need to sketch these parts. We will use convert entities, which is a really efficient way to convert sketches from other features into another feature. So select this face and press convert entities. This will convert the entities of the whole face. Now we need to trim all the unnecessary entities. This is not needed, but just for simplicity we are doing it. Okay, let's go to normal view and set the dimensions. This is 15 millimeters. And I don't know why it's not fully defined. This should be fully defined. Okay, there we need an angle and a depth. Depth is 10. Okay, this is 10. Okay, is there an angle to it? There is no angle to it, so okay. Okay, I have done a mistake here. This should be coincident. Okay, we cannot make it coincident. Let's just delete this line and it will be done. Why is it still not fully defined? It's because they don't know. Okay, this point should be let's say horizontal with the origin. Alright, now it's fully defined and it's a closed contour. We can extrude it 7 millimeters. Okay, let's go to extrude 7 and the reverse direction. Okay, we're done with the second feature. Now third feature is simple feature of 16 millimeter fillet. Select this face, choose fillet and 16 millimeters, enter. We are done with this one too. Now we need to select counter bore holes, two of them. Two let's go for this one first. Okay, let's go for the simple one first. This one is right across the middle of this, 30 by 22. Okay, so let's sketch on this face, draw a rectangle of 30 by 22, 22 by 30. Okay, now we have the point for that hole, counter bore hole. Let's go to features, uh, exit the sketch, go to features, go to hole wizard tool, select counter bore, and standard should be asymmetric. This hole has a custom size of 26 through counter bore is 34 and depth is 6. So from here we can choose to show custom sizing and input the dimensions as mentioned here, 26, 34 and 6. So 26, 34 and 6. Now let's go to positions, select this face and select that point right there which we just sketched, and right click, left click and right click to do it instantly. Now we can hide this sketch. This is not needed anymore. Now we need to create another sketch for locating these two holes. This one we can do. Okay, this one is 20, but we don't have this corner, so we have to use this corner to draw a rectangle of 40 by 40 and then another line of 60. So let's choose to sketch here, rectangle of 40 by 40 and another line of 60 millimeters. Now we have these 2 points as well. We will use these 2 points and draw another counter bore hole which has a custom size of, okay, this is not a custom size, but they have given us some. This is 30, in case instead of 34 there is 30. 6 is the depth. Oh, this is not a counter bore, my bad. This is not a counter bore. This has to be done using revolve workspace. Yeah, this has to be done using revolved cut. For this we need to sketch a plane that goes, okay, as the, if this face is curved we cannot use hole wizard tool in this face. We have to use a plane and use revolved workspace. So let's create another plane here which will be 40 millimeters from the front plane, which means this plane and this has a normal distance of 20 millimeters. Okay, so we have created a plane here and now we need to sketch on this plane. I wonder if there's a better way to do it, but let's just do it. Okay, I think instead of this simple, we need to think a little bit simpler. We can simply do this, which is, I think, a bit faster than just using revolved cut. Let's make all of this for construction and simply sketch circles, 20 is through all, so 20. Okay, let's use the same sketch. 30. This 20 will go through all, so let's hit extrude, select contours, this one right here and this one right here. Let's make it through all. Now choose the sketch again and choose cut extrude again. Now those two are already selected. We need to use an offset of 5 millimeters, and then we can use through all. I guess we are good to go. Our model is done. Let's do a final spin. It looks good. I think we did all of this. Now let's input the mask for this one. We took a lot of time, 11 minutes, but it's okay. We have done it accurately as far as I know. Let's go to evaluate and check the mask properties. The mass is 170.25. Let's see what they have asked. They have asked just for 3 digits, so it should be only 170 grams. Okay, you're correct. So this was the tutorial. The trickiest part was to sketch those counter bores, which are kind of inverted counter bores. I didn't notice that at first. I thought simple counter bores, but that was inverted along the arc, so it was kind of challenging for us. But in the end, we just simply separated the counter bore into 2 features by using 2 circles of 20 and 30 and using offset start condition. Okay, now I will try to speed model this, of course, as a separate video. Bye for now.